Example 2, part A and B are a little bit different because after you multiply by your least common denominator, you end up getting a quadratic equation, meaning that your highest degree is 2. Let's start with part A. I'm going to solve for 3x plus 2 divided by x minus 2 plus 1 over x equals negative 2 over x squared minus 2x. If you want to, as a first step, you can already decide which ones are the values that you cannot have as a solution. That way, instead of checking at the end, you just have to check whether they're part of the list or not. To do so, you just set all your denominators equal to 0. This is an optional step, but I find it a little bit faster to check my answers at the end. If they don't match any of the solutions, then they're an answer. If they match it, then they're not an answer, instead of substituting back my x into the x values. X minus 2 equals 0. That'll give me, after I add 2 on both sides, x, let me put it here, no solutions or not solutions. X cannot be 2, because if I put a 2 here, it will give me a 0. My second denominator will be x, and I just set it equal to 0. So 0, it's another not solution. And finally, for the last one, I will have to factor. If I set it equal to 0, x squared minus 2x equals 0, I'll use the zero factor property. I have x times x minus 2x, x minus 2, I'm sorry. I factor out one x on both. I divided both by an x. And then I have the same as the other two, if you notice. X times x minus 2. Which means I just get the same solutions again. X cannot be 0 and x cannot be 2. These are my not solutions. I'm going to put them aside for now. And I'll start the 3 steps that we have done in the past. First, multiply by the least common denominator, which means it's going to be one of these two, like these two multiplied. Because these two denominators multiplied give me this one right here. Let me rewrite it again, and then I'll leave some spaces for us to multiply the least common denominator. I'm just rewriting the equation again with some space left behind for the least common denominator. I'll have x times x minus 2. That's my least common denominator. X times x minus 2. I got it from here. When I multiplied, when I factored this one, I got that it was x times x minus 2. That's why that's my least common denominator. So this over here will be 1. The whole thing would be 1. I can reduce it because it's equal to 1. Then on my first term, that was the right side. On my first term, I can only reduce this x minus 2. And on my second term, I can reduce the x because those are equal to 1. I end up with x times 3x plus 2 plus x minus 2 times 1, which is x minus 2, equals negative 2. From here, I'm going to distribute x times 3x and x times 2. I have 3x squared plus 2x plus x minus 2 is equal to -2. From here, combining like terms and moving that -2 to the left side so I can have a 0 on the right side. But when I do so, I end up having that these two are canceled. And now, combined like terms, I have 3x squared plus 3x equals 0. I'm gonna erase my work and just focus on this part over here at the bottom. I want to solve this equation. Now that I don't have any denominators, it's easy for me to solve it. I'm going to use the zero factor property, where I factor out my polynomial, and I said the factors equal to 0. I can factor out an x from both. If I divide both by x, I have x times 3x plus 3 equals 0. And then I said each of my factors equal to 0. This is x equals 0. Remember, possible solution. And this would be 3x plus 3 equals 0. I subtract 3 on both sides. Now I have 3x is equal to -3. Divide both sides by 3. And I end up having that x is equal to -1. These are my possible solutions. I'm going to put here possible. Now, my third step, remember to check it. Are any of these solutions part of my not solutions? Yes, the 0. The 0 is not a solution, and my only solution is going to be x is equal to -1. Or if you want to use the solution set solution notation, solution set notation, I'm sorry, it's just -1. See how it was easier to first identify which ones are your not possible solutions, to have them in a corner, and then at the end, instead of substituting back your x, instead of going back to put the zeros in here or to put the -1s in all of your x's, it's faster just to check here in the not solutions options.